So we're going to look at 3.7, which is very short. Hopefully I can do this in like probably under 10 minutes. And it's solving systems graphically, which basically is just second calc intersect. That's all it is. So we'll look at it just in case you don't remember how to do an intersect. But then we're going to look at section 4.1, which is that's the section we rarely need to spend time on. So remember from Algebra 1 what a system is. A system is when you're solving for more than one variable. We're going to specifically be solving for two variables. And when you want to write down the answer to a system that has two variables, generally what we do is write it as a coordinate. We write it as an ordered pair. So when you solve a system, you need to make sure you give me two answers. One for the x value, one for the y value. If you only tell me one of the letters, you're missing half your answers. Some systems have 3 variables, 10 variables, 50 variables, and you can have as many variables as you want. I'm just telling you we're only going up to 2. Now, if you think about graphs, kind of already told you this, but if you draw 2 different pictures and you want to know where the pictures are equal to each other, that's where the 2 pictures would do 1 on the calculator. Cross, yeah. So graphically, where 2 things cross is the solution to a system of equations. It's where the graphs cross. Or you could also say it's the point of intersection. Notice I write point or points plural. It depends on what you draw. If you drew a parabola and you drew a line, well, a parabola and a line could cross twice. So you might have to find more than one coordinate as your answer. All right, so we'll do 2 examples, finding intersection points, and then that'll be it for this section. Okay, so the first example says, if you can't read it, it says 2x plus 3y equals 5. And negative 3x plus 5y equals 21. It says to solve graphically, but it's not ready to solve graphically. What do I have to do with both of these to be able to type them in on my calculator? Yeah?
You have to get y by itself.
I have to get y by itself. So if I get y by itself, in the top one, I would have negative 2 thirds x plus 5 thirds. And in the bottom one, I would have, let's see, we would add the 3x and then divide by 5. So add the 3 becomes a positive 3, divide by 5. So 3/5 x is my slope. And what would my y-intercept be? Yeah, you'd have to divide the 21 by 5. Now I already, again, kind of gave this away by saying the word slope and intercept. But when you draw both of these on the calculator, what are they going to look like? They're both what shapes? Yep. They're both just lines. And they're lines with different slopes. So how many times can lines with different slopes cross? Just once. So this is a very basic system. This is a linear system. So the way you want to type it in is negative 2 thirds x plus 5 thirds. And might be other ways you could do it, but that's how I do it. And the bottom one, we'll do 3/5 x plus 21/5. Now, these lines don't have a very big slope. They don't have a big y-intercept. So I would start with a standard window. And I'm pretty sure that you will see where they cross. It's right around there. Okay. So how do I get the answer with that graph? Yeah.
You have to find where they intersect.
Okay.
So you do second calc
And then intersect. Pick a point on the blue, the red, do your guess, hitting enter each time. And there, whoops, I did that last time too. That's the screen I want. X equals -2, y equals 3. Yes, you do have to give both numbers. So you can write your answer that way, or you could write your answer as a coordinate. Either way. Okay, questions on that? Yeah.
When you say as a coordinate, do you mean like as one?
Yeah.
Yeah, just as a ordered pair, x comma y. No, they have to be together. One, -2 has to be in the first part, the 3 would have to be in the second. Yeah. So let's try this one. So, little different. It doesn't say to find the solutions at all. It just says how many. So let's. Anything we need to do to get that ready to type in? Nope. Y is already by itself. Just type it in. So -x cubed plus 3x squared plus x minus 3. And the y2, -2x squared plus 5. Let's do zoom 6. And we're looking for the number of solutions. So there's your cubic. And you're going to get a parabola. Okay. How many solutions are there? Yeah?
2. Or no, 3.
There would be 3. I can tell that the blue and the red are getting closer and closer on the right side. If you want to check that out more, set the y min at like -50, something like that. And watch what it looks like now. It's going to be a lot more apparent that they cross. But there it was a little hard to see if you didn't look carefully. But there, no question, they cross. All right, so point on this one is make sure that when you're looking for where they cross, zoom out if you need to make sure you can see a complete graph. So the answer here is 3. Now, while we have that one up, I'm actually going to add to this one so we can skip the last one. Let's actually find the answers here. There are 3. So you'd have to do second calc intersect 3 times. Do it once and put your cursor closer to the left. Okay, so there's one answer. Do it again. Put your cursor closer to the other one. Hit enter 3 times. There's your second one. And do it one more time to get the one all the way on the right. Second calc intersect. This is where it was important to zoom out, because if it's not on the screen, you can't do second calc intersect. And yep, it was on the screen. So you could write your answers like that. Three things that you circle, or you could write them as 3 coordinates. So for this one on the test, I'd be looking for 6 numbers as your answers. This coordinate, that coordinate, and the bottom coordinate.
When you're writing those coordinates, how many decimals do you
Two would be good, yeah. Just 2. Any questions on how we got all 3? Okay, so that's 3.7. That was good. So that wasn't really the section we were spending the whole day on. There's only 3 questions from the homework on that. This is really the lesson for today. But that was a quick one, so we just took care of it. All right, rational functions. So chapter 4 is all about rational functions. Remember what rational means. Okay? What's another word you usually think of? If a number is rational, you can write it as a
Real number.
Well, square root of 2 is a real number, but it's irrational. So there's 2 types of numbers under real, rational and irrational. Yeah?
You can write it as a fraction.
You can write it as a fraction. So irrational function is one that you can write as a fraction. Specifically, the top and the bottom are polynomials. Polynomials is what we've studied in chapter 3. So the top can be any polynomial, and the bottom can be any polynomial. But when you create a fraction, there is one thing you're not allowed to put in the bottom, and that is 0. So the bottom polynomial cannot equal 0. If it could equal 0, we need to prevent that from happening. So we need to say that something's not in the domain. Yep.
Does it follow the same rule with like rational numbers, or like 6 is a rational number, so you can write it as 6 over 1. So like if you had x cubed minus 1, that would be a rational function because you can get x cubed minus 1 over 1.
Yeah, technically you could make anything a rational function by putting it over 1. Yeah.
Okay.
Yep. It's a really good thought. So here's an example of a rational function. X squared plus 1 is a quadratic. X minus 3 is a linear polynomial. And when I divide one by the other, I've created a rational function. I know there's a number that I can't use for x there. We'll talk about that in a second. Here's another example of a rational function. This time, a quadratic divided by a quadratic. Make up anything you want. Right? Put a polynomial on the top, polynomial on the bottom, and you have a rational function. Now, what did we say just a minute ago? The bottom can't equal 0. So if there's a number that would make the bottom 0, actually I should rephrase that. If there's a number or numbers that would make the bottom 0, then we need to make sure we eliminate those values from the domain. So the domain is all real numbers. You don't have to worry about imaginaries. All real numbers, except any number that would cause the bottom to be 0. So we're going to look at the same 2 rational functions I just put up and make sure we can identify the domain. You can tell me what the domain isn't, like what it does not include, but I'm more interested if you can write it so that you tell me what it does include. So let's start the simple way. What number are you not allowed to use for x? Yeah, 3. So you can include everything except 3. And remember how we write that? Negative infinity up to 3. So you can pick any number from 3, not including it, as low as you want to go. And what comes after this? 3 to infinity, so any number from 3 as high as you want to go, not including it. Something between u. This means or. So this is the domain. And there'll be something like that on the test. So in that case, finding the zeros of the denominator, not too bad. That one's a little more complicated. So to find the zeros easier in the bottom, what do you think we should do to the bottom? Yeah, you should factor it. Factoring is the whole point of chapter 3, right? We learned how to factor polynomials so we could find the roots. Okay, so that's going to factor as, you tell me. X plus 2, x minus 1. Not too worried about the numerator, really. Just want to focus on the zeros of the denominator. What values can't you use here? Luke?
-2 and 1.
-2 and 1. So if you think of it visually, you can use anything from -2 down. You can use anything between -2 and 1, and you can use anything above 1. That's 3 parts you have to write to describe it. How would you describe that part? -2 down. Christian?
From negative infinity, not including negative infinity, to -2, not including -2.
Yep. So there's that part. How would you describe the part between those two? Cassie?
Just a question. Is it on the number line that you have, it's -2 and -1?
Did I put -2? Yeah, +1. Thank you. Yeah, +1. How would we describe that middle part, which we would have got messed up on if I hadn't fixed that? Or if you hadn't. Oh. -2 to 1. Or, how would we describe the right part? 1 to infinity. And in general, you're not going to have to write more than 3 of them like that. That's probably the most we'll deal with. The last one, I'm not going to write it all out. It's actually a little easier than part B, because they already factored the bottom for you. But just tell me the 2 numbers that you can't use here. Yep.
X cannot equal 2 and -4.
X cannot equal 2 or -4. And you could write the answer just like we did the last part. Okay. Any questions on that? So I've shown you guys a few different reciprocal functions, or rational functions. But the reciprocal function, yeah, you too. The reciprocal function is the simplest rational function you can have. Right? Or it's considered basically one of the simplest. It's just 1 over x. That's called the reciprocal function. And it's a very simple rational function. Let's graph it. So if you look at 1 over x, what value are you not allowed to use for x?
0.
Can't use 0. So we know there's going to be a discontinuity at 0. You have to lift your pencil. And you know what? Let me put that on its own page so we can make it bigger. Okay, so there's the graph of 1 over x. And it's a little bit misleading because it looks like it stops. It does not stop. This part keeps dropping down, and this part keeps curving up. That's what the graph of 1 over x looks like. All right, so I want to look at that graph, and I want you to tell me, as x heads to the right, what happens to the y value on that graph? If you head further and further to the right, basically stay on the blue curve, what's happening to your y value? Yeah?
It's going down.
And what's it getting close to?
0.
It's getting very close to 0. But I don't care how far to the right you go. If you go all the way to the right when x is 500, is 1 divided by 500 going to be 0? No, it's going to be small. It's going to keep getting smaller the further to the right you go, but it will never be 0. Now, same thing goes to the other side. If you keep heading further and further to the left, like if x was negative 20, 1 divided by negative 20 is a small negative number. If you go to negative 2,000, well, now it's an even smaller number, but it's not 0. So this graph is approaching 0 if you keep heading further and further to the right, or you go further and further to the left. So as x approaches infinity or negative infinity, your y value is getting closer to 0. And if, as you go left and right, if you're getting closer and closer to a value, that's called a horizontal asymptote. Usually the way we show a horizontal asymptote is with a dotted line. So if I go to that graph I have on the other page for a second, this is how I would show a horizontal asymptote. It's a dotted line, and it's a line that my graph never touches. It gets closer and closer and closer to it. Yep. And the way that you find a horizontal asymptote is you look at your graph and ask yourself, what's happening to my graph if I keep going to the right or to the left? Is it getting closer and closer and closer to something but never actually reaching it? If it is, then you have a horizontal asymptote. Parabolas don't have horizontal asymptotes. In a parabola, if you head further and further to the left or the right, you're not getting closer and closer to a number. You're approaching infinity in that case. But rational functions will usually have horizontal asymptotes. A lot of times. Yeah.
Does the asymptote have to be on 0?
No. Nope. Because I'll show you why. No, it doesn't always have to be on 0.
When it says the line that equals 0 is a horizontal asymptote, does that mean that it's a horizontal asymptote of just the equation f(x) equals 1 over x?
Yes, this specific problem. Yeah. So y equals 0 is a horizontal asymptote for this particular problem. Here's a couple more pictures of asymptotes. So the dotted line represents an asymptote, and the curve represents a graph. These aren't rational functions. I don't know what these graphs are. They're just ones I made up. But in both cases, it's getting closer and closer to that dotted line. But as you continue heading to the left forever, it will never reach it. Now, this one crosses the asymptote. We don't really care, when we talk about asymptotes, we don't care what happens when we're only at like x equals 5 or 10. We care what happens when we're at like x equals 1,000,000. What happens when you're really, really far down? So if it crosses here, that's fine. But as I continue heading to the right, it is getting closer and closer and closer and closer. In fact, even a graph that did this. That dotted line would be considered an asymptote. Because as I continue to head to the right, that graph in blue is oscillating, but it's oscillating closer and closer and closer to the asymptote. So there's all different kind of things you can look at with asymptotes. In the case that what we're doing, usually rational functions do not touch the asymptote. They don't cross it. These are other kinds of graphs that have asymptotes. Yep. Yes.
Are there vertical asymptotes?
Yes.
Are they in line?
Yes. That's the next thing. All right, so remember how to find a horizontal asymptote. Think about what happens as you let x become a really big number or a really big negative number. So let's look at this formula. And think of that formula as being in like a box. I want to know what would happen inside this box if you let x get huge. I want to know what the result inside the box would get closer and closer to. So anyone think they could tell me what you would get inside the box if x gets bigger and bigger and bigger and bigger and bigger and bigger? It just keeps getting bigger. Yeah?
Would it be getting closer and closer to 2?
It would be getting closer and closer, but never reaching the number 2. Because if this is like 5, you'd have 1/5 plus 2. If it was 100, it'd be 1/100th plus 2. It's 2.01. So it'll be getting closer and closer to 2. How do you write the equation of a horizontal line? What letter does it always start with?
Y.
Y. Do not mix up horizontal and vertical. If the problem on the test says horizontal, you need to write y equals. If it says vertical, well, we'll talk about that. So what this basically is this is a rational function shifted up 2. Whenever you add or subtract a number on the end of your rational function, that's a shift up or a shift down. And that's just like a parabola. If you add or subtract a number on the end of your function, that's a shift up or down. So it's the same thing we learned. Positive is up, negative is down. This is still another shift. This time it's a shift down 3. So what would be the equation of your horizontal asymptote if you let x get bigger and bigger and bigger and bigger? What would happen to this calculation? What number would it get close to? Yeah?
-3.
Negative 3. It would get closer and closer and closer. But would it ever equal negative 3? No. I mean, even if you let x be 10 billion, 1 divided by 10 billion is extremely small. And minus 3, it's not quite negative 3, but it's very close. Any question on that one? Yeah. If you remember, let me know. Now I want to think about the same graph again, the graph of 1 over x. So I'm going to go back to the picture. But this time, I don't want to look at what happens as x heads to infinity or negative infinity. I want you to look at that graph and tell me what's happening as x gets closer to 0. Let's start with the one in quadrant 1. As you travel on this blue line, approaching 0, keep heading left. What happens to your y value? Increases to what? Infinity. As you get closer and closer and closer and closer to the y-axis, as you head towards 0, your graph heads to infinity. That's as you head towards 0 from the positive side. This is the positive side, this is the negative side. What happens if you're on the negative side and you start traveling closer and closer to 0? What happens to your y value in this case? It goes down to negative infinity. So as you travel towards 0 from either direction, your graph either curves up to infinity or down to negative infinity. When a graph does that, you have one of these, which is called a vertical asymptote. Okay, so when a graph all of a sudden goes to infinity, negative infinity, here's another example of a graph. If you had a graph that curved up and it was getting closer and closer and closer, that has a vertical asymptote because it's heading towards infinity. All right, so let's look at that. So the first one we looked at was as x approached 0 from the positive side. As x approached 0 from the positive side. All of a sudden, your graph approached infinity. And then we looked at it on the other side. As x approached 0 from the negative side, negative means left side, positive means right side. As you came towards 0 from the negative side, your graph curved down to negative infinity. That behavior indicates a vertical asymptote. So in this particular problem, x equals, very important, vertical, x equals 0 is a vertical asymptote. Well, how would you know that it's 0 if you didn't have a picture? It's actually pretty easy. Look at the original problem. What number was not in the domain? 0. The number that's not in the domain is generally your vertical asymptote. So if you know how to find the domain, then you automatically know how to do vertical asymptotes. Now I said generally, because there is one little thing I need to mention. But if you can find where the denominator is going to equal 0, you can find your vertical asymptotes. Yep. So how about if I had something like y equals 1 over x minus 2? Where would my vertical asymptote be? Yeah? At 2. This time, we did some addition or subtraction, in this case subtraction, but it wasn't on the end. It was inside the fraction. So when you add or subtract on the end, it moved the graph up or down, which affects the horizontal asymptote. But when you add or subtract in the denominator, which way is that going to move in?
Left or right?
Left or right. So this affects the vertical asymptote. So this is the idea that you look for an asymptote. If, as you approach a certain number from either side, are you heading to infinity or negative infinity? If so, that's the behavior of an asymptote. Yep.
So for a graph that's like, I can't like that would be a good one that they're both coming up.
Yeah. Yeah, that actually would be like the absolute value of 1 over x, I think. Let's see if that works. I think, graph, you said you're talking about them both going up. Yeah.
So with that one, it's like, so it would still be true that as x approaches from 0, or as x approaches 0 from the right side, f of x increases.
Yep.
It goes towards positive infinity, but from the left side it also does.
Now the left side it also does. Yep.
So what we're writing is just applicable to like 1 over x.
Yeah, that's just specifically for that one. But in this one, as you approach 0 from either side, you're going towards infinity now. So that one's a little different. And again, it looks like it stops. It doesn't stop.
Are there going to be any equations like that, like that we're doing on homework or anything?
With absolute value?
Yeah.
I have to double check. So I said to you that if you can find when the denominator is 0, that's when you get a vertical asymptote. But there's one important catch to that. The numerator and the denominator cannot have a common factor. So if you had this, x minus 2 over x minus 2, x plus 3, there would be a vertical asymptote there at negative 3. But at positive 2, there would not be an asymptote. Does anybody remember what happens on the graph when you share a common factor in the top and in the bottom? It's not something you can see on the graph. You have to know it's there from the equation. Yeah?
It cancels them out.
Okay, it's kind of like it would cancel them out. And what's the result on the graph? Yep.
It's like a hole.
It's a hole. So in this case, you would have a hole at 2 and an asymptote at negative 3. The hole you wouldn't see. The asymptote you would definitely see. Yes. Sorry. Lower?
No.
Higher.
So for purposes of like, if we're just doing it, I don't know, like what we're doing today, can we simplify that, or do you want us to keep it like that because we don't want to show that it's just
You're not going to have to worry about simplifying. The only kind of question I'm going to ask you today is like this. Find the vertical asymptote.
Okay.
So I'm going to be looking that you write down something like x equals, and I'm going to look for a number of months.
Hold on.
You don't have to write down this thing in green. That was just an example I made up. All right. So when I see a question that says find the vertical asymptote, first thing I want to write down right away is x equals. Don't put y equals. That's horizontal. X equals. And what would be the value that would make the denominator 0? 2. And that's your vertical asymptote. How about this one? What would be your vertical asymptote for b? The whole equation, not just the number. Yeah? X equals negative 3. How about if I did this? X equals negative 3.
That only affects the horizontal.
That only affects the horizontal. Remember, this is movement up and down, so it affects horizontal things. This is movement left and right, so it affects vertical things. I should probably describe those transformations right now. So if you have something like 1 over, could be a plus or a minus. We'll call that A. Let's call this number B, and plus or minus C. Well, A is the first thing you would look at, and adding or subtracting inside, which way did I just say that moves it? A moves it, no, yep,
Left and right.
left and right. So that's a shift left and right. Positive would be left. Negative would be right. C moves it vertically. Positive would be which way?
Right. Or up.
Up. Negative would be down. And what about, let me fix that arrow, looks awful. And what about when you multiply by a number in front? What does that do? Like 3x squared versus x squared. The 3 would be a...
Does it stretch it vertically?
Yep, that's your vertical stretch. So this is what you're looking for when you're trying to describe a rational function and how it's being changed. It has to be written as 1 over something. You have to have a 1 here. Because a 1 is what we used here. It's what we compare everything to. The fraction that had a 1 in the top. One other thing I could mention, what if there was a negative in front of the b? What would that cause the graph to do? Yep.
Flip over the x-axis.
Yep. This would cause a vertical flip, which you could say is a reflection over the x-axis. Yeah.
Would you be able to say vertical stretch of negative b?
No, you describe these as two separate things. So you'd want to say like vertically stretch by a factor of 3 and then reflect separate. We're going to do an example where we describe transformations in a second. But I want to get that chart up first. Yeah.
How do you do a horizontal?
So a horizontal stretch or compression, I don't think they talk about it in this section.
Not a stretch, but like
Oh, horizontal flip?
yeah.
Right there.
Okay.
So I guess I can put that in. That would be a horizontal flip. Not sure we're going to have that in this section. Probably going to make that one down. All right, so now what I'm asking you to do directly relates to what we just did. I want you to use that idea to describe the transformations in this rational function. But is that rational function written with a 1 in the top? No, it's written with 2x minus 13. It's not set up the way it should be at all. We have to write it with a 1 in the top. And there's only one way to get a 1 in the top. Divide that out. Find your quotient and find your remainder. And then you can rewrite it. Remember, when you divide it out, one way to write your answer is quotient plus remainder over divisor. That's how we want to think to write our answer this time. So we looked at that when we did dividing on Tuesday. Quotient plus remainder over divisor. Okay, so let's divide it out. Can I use synthetic division to do this one quick? Yeah, it's linear in the bottom as long as it's not x squared or anything like that. Let's put 5 on the outside and let's divide this into that. I don't expect it to go unevenly. I expect to get a remainder. So let's see what happens. Put 2, negative 13. It's going to be a very short synthetic division. Bring down your 2. 5 times 2 gives me 10. And 10 plus negative 13? Negative 3. So now, here's your quotient. Here's your remainder. Let's think about writing our answer like I have in black. So f of x would turn into quotient plus remainder over my original divisor. Okay, so that's better. It's starting to look a little bit more like this, except what we have now, the negative b is essentially in the top. We don't want the negative b in the top. Right? You have a fraction, and you had a 3 in the top of your fraction. Well, you can write it with a 1 in the top. Just go like this. 3 times 1 over x. Take the number that's in the top and bring it out in front. And then you'll see your vertical stretch. So let's do that. Take the number that's in the top and bring that negative 3 out in front. Now I can see that it's negative 3, so vertical stretch and a flip. And this 2 plus, we normally don't put that in the front. What we normally do is put that on the end. So let's put the plus 2 on the end. And then this should look exactly the way it's supposed to figure out the answer. It's negative 3 times 1 over x minus 5 plus 2. There's your equation. So the first thing says describe, well, we'll describe the transformation, then we'll do the asymptotes. Start with the negative 5. What would the negative 5 do to that graph? Yeah? Negative is going to bring it to the right. Yeah. So shift right 5. Okay. What's the next thing we would focus on? Yep. And that's a vertical stretch by how much? Yep. Well, no. 3. The negative is a separate thing. What's the negative in front do? Yep.
So this is a transformation from the graph of f of x equals 1 over x.
Yes. From the graph of f of x equals 1 over x. Sorry, what's the negative do? You said, which way does it flip it? So yeah, we flip vertically, or we could say reflect over x-axis, either way. And what about the plus 2 on the end? Yep. Moves it up 2. Okay, that's the hard part. Now the easy part is to write the asymptotes. Let's start with the vertical. What number would make the denominator 0? Yep. 5. So there's your vertical asymptote. And the horizontal is what that whole thing approaches as x gets bigger and bigger. So think of it as y equals. Well, pretend x was 1,000. If you fill 1,000 in right there for x, what would you get in the bottom if you filled in 1,000? Yeah? You get 995. And what's 1 divided by 995? Like, generally, it's pretty small. It's getting close to what number? It's getting close to 0. So this entire fraction is getting very close to 0. So if you take something that's getting close to 0 and multiply it by negative 3, it's still getting very close to 0, because 0 times anything is 0. But then what's left? Plus 2. That's my horizontal asymptote. Y equals 2. If you want to exaggerate it even more, let x be 1,000,000. 1 divided by 999,995 is basically 0. Times any number is still basically 0. Plus 2 is extremely close to 2. Okay. question out there? All right, so we're at the last slide. So we've done this kind of problem before. We've done mixture problems. This is actually a little bit easier than the type of mixture problem we've done before. But we'll go through it and I'll show you what's going to happen, and we're going to need the calculator to solve. So we're not going to do this with algebra. We're just going to graph it, and we're going to calculate an intercept. That's why I did 3.7, to remind you of how to do that. So let's say that you had a bunch of liquid in front of you, and I said to you there's 50 ounces in that container, and 35% of it in the container is acid. How would you figure out how much of the liquid in front of you is acid? It's 50 ounces, and I said 35% of what you're looking at is acid. The rest of it is water. Yeah? Multiply 50 times 0.35. So that would mean out of the 50 ounces sitting in the container in front of you, 17.5 of it is actually acidic, or whatever it is. It's the acid in the solution. That's important to know how to do for our problem. And that's going to bring us to our last example. So what I'm going to do in this problem is I'm going to take this liquid of 50 ounces, and what I'm going to do is I'm going to pour acid into it, pure acid, 100%. So I'm going to make this solution stronger. It's a 35% solution right now. I want to make it stronger. So I'm going to put pure acid into it. How much am I going to put in? Well, I'm going to pour X ounces of 100% pure acid into the solution I already have. I want to write a formula that shows me what the concentration is as I'm pouring the acid in. If you're not sure what concentration means, in our particular problem, concentration is going to be the amount that's actually acid divided by the total amount. Just like if I said, what's the concentration of questions you got right on the test? I would take how many you got right, and I would divide by how many there were, and the concentration of questions you got right, that's your grade. It's the percent that you got correct. So find a graph for the new concentration. So we need to write down the amount of acid we have divided by the total. So the first thing is, how much acid are we already starting with? That's there no matter what. We've got 50 ounces and 35% of it is acid. Yeah, we already did that. 50 ounces, 35% of it is actually acid. So out of the 50 ounces, 17.5 is already there. Okay, we can't get rid of it. That's acid that's in the water. So we have that much acid in there already, plus how much acid am I adding to the mixture? X. That's the new amount of acid in my solution. 17.5 is what I had. X is what I'm adding. Now I need the total. How much liquid did I start with before I put anything in it? That's going to be there no matter what. Yeah. Started with 50. And how much liquid am I adding? I'm adding X. So there's a graph of your new concentration. Oh, that's great. Yeah.
Why don't the X's cancel?
Because it's addition. If it was multiplication, you could. But they don't cancel with addition. Try an example with just other numbers, like 2 plus 6 over 8 plus 6. You can't say that the answer is 1/4. The answer technically is 8 over 14, which is not 1/4. So, yeah, let's take that in. So they want us to graph it. So put it in parentheses, that's the best way, so we don't get messed up. Divided by 50 plus x. Let's think about our window a little bit. In this case, my y value is a concentration. Concentration is going to be between two numbers. What could the concentration of a liquid be between? You could think of it as a percent, but I need to think of it as a decimal. Yeah?
Oh, for a decimal.
Decimal. 0 and how much? 0.1 would be 10%.
Oh, 1.
1. So the concentration has to be between 0 and 1. And x is the amount of liquid I'm adding. Well, I can't take liquid out, so it can't go negative. And let's say I add up to 200 ounces. I don't know. Will the concentration ever reach 100%? It's like if you had white paint and you keep pouring in black. I don't care how much black you put in, it's still never going to be black. It's always going to have a little bit of white that's in it. So the concentration will get higher and higher and higher, but it will never reach 1. Okay, so there's a graph of your concentration. So there's a sketch, and they want to know how much acid do we have to add to get exactly 75%. So I have to put a line on this graph somewhere. Put a line at 0.75. Okay, I went farther than I needed to. And what do you think I have to find on that graph? The intersect. So if I add 80 ounces to what I already have, if I add exactly 80 ounces, it'll bring my solution up to a 75% mixture. That's it. So I am going to put a list of topics. I'm going to have to do that after you guys leave, but I will put a list of topics with this page that describes what's on the test. So page 207, that's finding intersects. So just 3 of those. And then most of the homework is 4.1. 48, I think it has 3 parts, A, B, and C. I didn't show you part C, so you can just skip it. Just do parts A and B. I will put the topics for the test right below that, right after you guys leave.